example, call it DiceRoller. This DiceRoller example is reusing some code from my dice, but it has additional Java features that I want to discuss. And particularly, it has introduction to generics. What is generic? It's a container type for to store lists, sets, hash maps, this kind of stuff. So the primary purpose of this is to demonstrate generics, explain the concept of it, and introduce idea of dependency injection. What is dependency injection? In this case, it's manual dependency injection because we do it brute force. And when we we'll start dealing with web projects, there is a framework that does it automatically. So let's close this project the same way. So I go to GitHub, click code, copy URL. Now, if you want to keep project open for some reason, for possibility of copy pasting or for comparing, fine, you can clone project even if you have some other project open. How to do it? You click here, new, get from version control, and you get the same window. This way you can have two projects open. One, it is opened for some other reason, and one will be opened because you clone it. Okay. So you don't have to close other projects if you need them to be open. So now Control V, and again, I want to make sure that it goes to right place. So Java, fine, DiceRoller, Java. Okay. As this name doesn't have to be this name, it's just folder name, you can edit it. And clone, again, check that you're creating folder for your project. And clone. Now it will ask, do you want it to go into this window or separate one? I'll say new one, because otherwise I will just close this one. What's the point, right? Now it is copying it. And it is building. It's done, right? So let's open this project and see what is there. Some of it is copy-pasted. In particularly, I copy-pasted dice class. It is exactly the same. Actually, you can copy-paste entire class. You right-click on it, say copy, and you paste, and it will work if you do so. You don't have to create empty file and copy-paste what is inside. You can copy-paste the entire file this way. So I copy-pasted dice. I copy-pasted rollable. Rollable is interface where we have only one method, roll. And dice is implementing given interface. In Java, we can implement as many interfaces as we like inside of one class, but we can inherit only from one class. Right? And we use different keywords. For inheriting from interfaces, we use implements. For inheriting from classes, we call extends keyword. I got dice. Let's see what else do I have. I have dice roll data. Dice roll data contains a list of integers. So this example imitates rolling several dice. So let's run main to see what it is producing. So I created a DiceRoller service, new DiceRoller service, and I passed dice into it, just one. So this service imitates 4 dice, but how does it do it? It just calls the same dice 4 times. From logical point of view, it doesn't matter if we roll 4 dice or just roll 1 dice 4 times. So this is doing this. Just picks the 1 dice and roll it 4 times. Imitation, it's imitation like we have 4. right? And I got service. I ask get raw data for 4 number of dice. I got raw data and I print it. Raw data contains toString method, so toString will be applied to automatically to convert raw data to string. So we get nice string here. Raw data values 5242, total 13, number of dice 4. So my raw data contains a list of integers. I could use array if I want to, but I use at list to explain the concept of list. So let's go back to raw data and see what is inside. I have private final. Final means assign it once, you cannot reassign it. A list of integer. Please notice that this is not the same as this int. Right? This int, it's primitive type. It's just a value, it's not an object. It does not have a methods in it, doesn't have any data fields except the one piece of data, this integer. But this is actually object. So in Java we have pairs between primitive types and object types. Primitive types are passed to methods always by value, by copying the value. Right? So if you pass this into some method, it will pass the copy of it. So you cannot change this value inside of a method. In Java, all objects are passed by reference. So if you pass integer to method, it will pass copy of reference. It will not be copy of reference. So it's still copy, but reference. Okay, but it doesn't mean you can change it. And because integer is immutable type, you cannot change value inside of this object. So although it is passed by reference, it doesn't get any side effects, like you can change what is inside. No, you cannot pass data backwards this way. You cannot change it what is inside in order to pass it back. Okay. So integer, double starting with capital, they are all immutable types. The same as string. String is immutable. It means you cannot change what is inside. In order to produce new integer, we just add 2, it will create new object. The same about strings. When we join strings, it creates new objects, which is string. So why we have class type, but this is immutable. This is primitive type. When we use generics in Java, we can use only class types. We cannot use primitive types. You're familiar with generics from your C# class, right? In your C# you can create list, you can create hash maps, right? Hash maps, you can create sets. The same applies to Java. You can create hash maps, sets. In Java, you can use only objects in order to create generics. Object types in order to create generics. In C#, all variables are objects. You don't have primitive type at all in C#. If you declare something with int, it is actually object. You can call methods of it. So there is no difference in C# because between integer and this kind of type, because in C# this does not exist at all. This is why there's no difference. But in Java we have 2 different kinds. In C++, you know that you can create templates. You can use templates to create a list of integers, ints, right? And in C++, int is primitive type, not a class. Why we cannot use primitive type in Java to create lists? The reason is that generic in Java is not the same as template in C++. In template, template is generating class. But generic, it's already existing class. So it's not generating anything. What does it do under the hood? It is typecasting. In Java, all objects inherit from parent class called object. So what it does under the hood is to create a list of objects, generic like parent class, and does typecasting, and is doing typecasting. So it's not creating new classes. So technology under the hood is totally different from templates in C++. And the same technology is used in C#. So objects, generics in C#, the same as generics in Java. The same technology, typecasting. So this is the reason for doing it. A list is interface. It's not class. It means that we cannot call constructor of list, but we can call there are implementations, and we will call constructor of implementations. So let's see what we have here. So this class is intended as immutable. Final, it means you cannot reassign this variable. What about list? Potentially we can add items to the list. And when we add items to the list, we don't change this variable, we change what is inside. Right? So technically, if I leave it as it is, it is not immutable. And this is why when I call path list to the constructor, I call collections unmodifiable list for this value. So values stored here is actually unmodifiable list. So it sets some flag inside of list, do not change it. So this makes it truly immutable. Create unmodifiable list. Then in the constructor, I assign total. See, total is declared as final because it is assigned from the constructor. And once after this, it's not assigned. So if we declare parameter final, it means it's assigned once, either immediately or from constructor. So what this is for? Explaining how to do for each loop in Java. Right? So in C# you learned about for each loop, and for each loop in C# works exactly the same, except you use in keyword, right? Int value, in values. In Java it is just column instead of it. In total, assign it to string, public to string, and I'm showing how to format a string. We can create a string by joining, right? Or we can call string format. And please notice the rules are just like in your C class, right? Rules for the template are the same as rules for C, printf statement. And you can also specify a number of digits, before dot, after dot, when you do that. Right? This is integer, so this no before dot, after dot. But you can specify field, padding with zeros, no padding with zeros, so this is extremely flexible. So what's this for? To show that we can format strings, similarly to your C class. When you took your programming languages course, right? You had C, and you learned how to use printf, fprintf, right? So it is the same rules. Questions? No? So let's continue. So this is raw data, and DiceRoller service is taking rollable as a parameter to the constructor. It means it doesn't have to be dice. It can be anything that has roll method, right? Which is good, because what if I want to test this class separately from my dice class? Maybe I should, right? Because classes should be testable separately, as much as we can. Right? So I could make a lot simpler class for dice to make sure it never fails because it's immediately obvious. For example, roll returns number 2, right? Always. Why not? Because rollable, it is whatever that is returning, whatever has roll method in it. If my rollable is returning roll with always return number 2, it will be extremely easy to test this logic, right? Because it will be always the same number, but who cares? I'm not checking dice, I'm checking this method. So number of dice times 2, it will be total. Easy to check. I don't even need to run a loop to check it. So rollable is dependency of DiceRoller service, right? It cannot exist without rollable. It cannot do the task without rollable. But it doesn't have to be dice. It was whatever is roll. If I want to use it as dice imitation, I can put any implementation of dice, so it doesn't have to be that specific. If I want to test it, it is whatever that has roll method in it. Okay. So rollable is dependency of DiceRoller service, and this dependency is provided to the constructor. So this kind of dependency link to the constructor is called constructor dependency injection. So we have dependency, we put it into constructor parameter, we inject dependency into constructor. So it is constructor dependency injection. Okay. We did it manually because this is manual dependency injection, because we do that broad force. We created an object called constructor ourselves. There are frameworks to connect objects by dependency injection. Spring Boot framework is doing this automatically, but we need to provide descriptions how to connect them. So we will learn it. This Spring Boot framework will start learning it today, and it will continue until end of the course. Right? So Spring Boot does have option to connect objects by dependency injection. What other options are available? To provide it to constructor, or I could call setter method, right? Technically, I could call setter method if I create one, set rollable. This would be called either setter injection or the same as method injection. When you call setter or some method to connect to dependency. So we use method injection only when constructor injection is not possible because of internal logic. It could be some circular dependency between classes when we cannot use constructor injection because of it. We create setters for that and inject dependency using setters. There are other options to do dependency injection. One more is to do field injection. Field injection is not recommended for a reason that if we use field injection, it's making it harder to test given class. So what is the field injection? Rollable is passed through constructor, so it is constructor injection. But it is possible to access even private field inside of the class. It is possible, but it's difficult, but it is possible. The reason is that all more modern languages such as C# and Java do have a feature called reflection. Reflection, what is reflection? Every object provides not just data, it also provides instructions what else inside, besides data. And also provides options to call any methods, even private, access any data, even private. So this is called reflection. It is inconvenient to do it, but if it is done by framework, by some other code, who cares, right? If we don't write our own code, some library is doing it. So it is possible to assign dependency, even if it is private, using reflection. Spring Boot can do it for you. You don't have to write a lot of code for it. But assigning dependency this way makes the code hard to test, because when you test it, you don't typically do dependency injection with the framework. You call the method yourself and you call constructor yourself. And you cannot access private variable easily unless you do the same reflection in your code. And this will be harder to do. So bottom line, field injections are not recommended in any class that is not test class, because we do not test classes. Right? We test any class but not test class, right? Because test class is used to test something else, right? We do not test classes. So do not use field injection anywhere outside of test class. Okay? Because this will make the class hard to test. But we do not test. Okay? Obviously. Questions? So, and we will see how dependency injection works in Spring Framework at the next lesson. Now we saw just manual and only constructor. In setter, you know what it means. I would create setter, set rollable. It's obvious. And field injection, don't do it, essentially. Unless you have some, no, there's no good reason for it. So what is the next? This project does not have tests in it. You can call it bug, but I may say maybe it's feature. Why maybe it's feature? I want you to create some tests yourself. It doesn't have to be exhaustive, just to practice that you got how to generate it. Just create a couple tests per class. It's not for grade, it's practice. But you may run into some issue that I ran it in the previous lesson, so let me talk about this issue. If you generate tests the same way in the cloned project, you may get this message. You click generate tests, you see no root, because no, cancel. Okay, don't click OK. You see, because this exists, but this doesn't. I don't have a, okay. No, not a big deal at all. You just need to create it. Okay. So right click on source, a new directory, and what is missing? Test Java, right? Click on test Java, press enter, and you got test Java. So it is complaining because this doesn't exist. You just create it, and this is it. And then after this, you click Dice, then click Generate, Test. Doesn't matter because you can copy paste it, exactly the same class. It's not a big deal. For this one, you can just copy paste. And click OK, and you got it. You add it to version control, you got this one. But for raw data, you cannot copy paste it because it doesn't exist on that project. If you want to generate test the same way, DiceRoller, generate, test, generate. You can always delete things that you don't want to test. You see it's JUnit 5, it means Jupyter. Jupyter is the same JUnit 5. And click OK, and add to version control. So this is in red because it doesn't know what to do with it. Now, when you click add, it will turn into green because it's new, not committed. Add, add sum, check if it's working. And the same about service. Generate, test, and so on. So play with it. As exercise, it's not for grade. Doesn't have to be exhaustive because making all possible tests takes time. Some is better than none. Right? So play with this on. Questions? So as exercise, add some tests, play with them, see that you can do it. In the test, you can play with some fake dice that does not produce random number, because this way you can check easily. For example, create rollable that returns number 2, for example. This way, sum is always the same. You can easily check it for different number of dice. Number of dice times 2, for example, sum. Okay. Questions? If no questions, I think this is the end of the story about DiceRoller.